We have taro, also known as elephant ear. We have ginger. We have Egyptian papyrus. We have canna lily.
Matt Beam likes to be around plants when he works. It makes sense because most of the time he's thinking about ways to put those plants to work for people.
These are all enormously important plants throughout history. Obviously, papyrus is known for making paper, the first paper. Taro is the root is almost like a potato. It's a food staple in parts of the world. I'm not necessarily advocating that we start eating things out of the Eco-Machine, but the point is that we can grow useful things in Eco-Machines.
The Eco-Machine in question is one of the green features in the newly renovated George D. Aiken Center at the University of Vermont. It's designed to treat the building's wastewater for reuse, which is a lot more complicated than just growing the right plants.
The Eco-Machine is basically using biological organisms to treat the waste in the building. So we don't have to send any waste into the sewer system, into the city sewer system, which ultimately ends up part of it into the lake. So we're doing our part in kind of recycling water. Once that water's cleaned by the Eco-Machine, we use it to reflush toilets. It comes back to the Eco-Machine, gets cleaned again, and is reused.
The Eco-Machine is the final result of many years of collaboration and planning.
I worked with probably 2 years worth of students in John's ecological design studio class, as well as a lot of John's other master's students and John himself, his company, and their engineers, and worked our way through it.
Beam, who started at UVM as an art major, found his way to the Rubenstein School of Environment and Natural Resources, where he wound up with an ecology degree. Along the way, he met UVM professor John Todd, who's a pioneer in the field of ecological design. Beam came back to UVM for his master's degree, which turned out to be designing this Eco-Machine.
And one of the neat features of these particular racks is that the plant support is built into it. We try to take the wisdom of nature, and one of the biggest wisdoms of nature is biodiversity.
That biodiversity begins with the microorganisms that form the base of the whole system.
We spin a whole food web off of it, and those become the base of an ecosystem, the food base, basically. You grow plankton, you grow algae, you grow higher plants. You even add oligocete worms and other invertebrates.
Biodiversity will also help the Eco-Machine to bounce back from shock if something unexpected gets put down the drains. Otherwise, the system is designed to roll with the punches, so to speak.
We can pop this, and we can raise or lower the overflow, and that'll change the water level in all 3 of these tanks. The water that comes in here it's from the septic tank. It's been sitting there and going anaerobic, and it's really gross. It smells like what you would imagine wastewater from a bunch of people would smell like.
That wastewater moves through a series of tanks that begin to break it down.
It just settles out the solids, and it separates the fats, oils, and greases. So it draws water from the middle, solids settle out at the bottom, fats, oils, and greases at the top, and basically from that point on, you're just dealing with soluble pollutants and soluble nutrients.
That process continues, moving the water through even more tanks and more biology until it's clean. Then it gets reused and the process starts again. But that's not quite the end of the story.
Right now we have a real disconnect. We're not fitting well into our environment. We generate our fertilizer by digging up phosphate rock, which we're running out of. And we also generate it by getting nitrogen from natural gas. At the same time, we're polluting all of our waterways. Phosphorus is a huge problem in the lake, and we're running out of phosphorus for agriculture. So we need to close this loop. We need to fit within our environment a little better, and we need to start figuring out how to mine phosphorus.
Now that the machine is in place, there's research to be done.
We'll be looking at nitrogen, we'll be looking at BOD, we'll be looking at phosphorus, which I'm sure our viewers by now have heard about phosphorus from all these shows. But we're also looking at some of these emerging pollutants, so caffeine. goes right through us. Estrogen in birth control pills. The amount of, we don't even know the names of most of them. Thousands and thousands of new chemicals are coming out in health and beauty products every year. And no one's monitoring for them, no one's testing, and no one's really sure what they're doing out in the environment. We really want to look and see how well Eco-Machines can remove some of these endocrine disruptors and some of these also emerging pollutants that aren't normally monitored for.
There's a world of questions out there waiting to be answered by the world that's been created here in the Eco-Machine. Beam, who finished his master's degree in 2010 and now works at UVM, is looking forward to answering those questions, all the while taking his cues from nature.
Nature is incredibly good at not wasting energy.
The new Aiken Center at the University of Vermont is paving the way to a more environmentally friendly future and will continue to provide research opportunities that benefit Vermonters and the environment. In Burlington, I'm Rebecca Gollin with Across the Fence.